Hello, math people. We're going to talk about area of compound shapes today. And our focus is on a process of subtraction. So what is different from what you have been working with previously is in our compound shapes, you are again observing shapes that are not singular. So for example, first example right here, we have a circle and we have a triangle. So there is a couple things that is happening. We have a variety of shapes. That's why we call them compound shapes. And why we're going to be subtracting is because these shapes, the way they are created, one shape is changing the area of another shape. So in our first scenario, we have a circle and a triangle. So what I would like for you guys to do is to separate your shapes, just a little sketch, as we work on creating or determining our steps and determining the area of compound shape that we have in front of us. So we have a circle. Our circle has a radius of 6 centimeters. You might say, well, how do I know this? So I am using this measure right here. This is my line segment that goes from the center to the outskirts of my circular shape. And so that is the measure of radius. In order to find the area of circle, I know I'm going to be using formula pi r squared. Okay, so I have 3 14/100 times 6 squared. So 6 squared means 6 times 6. So pi times 36. That's the number that I'm working with. That gives me the area of 113 400 square centimeters. We have found the area of a circle. But we know that we do not have the full area because the triangle has been cut out of that circle. So that now our area would be reduced by the area of this triangle. All right, so let's label our triangle. It seems like we have very little information about this triangle. However, guys, when we have the radius measure right here, I hope that you realize, I'm going to use my pencil here, I hope you realize that the radius measure goes all throughout this triangle, this circle. And yes, it will give us enough of information to find the measurements for our triangle, because the radius would go here, and it would go here, and yes, it will go here to give us very, very important measurements. So the height of our triangle would be 6 centimeters, and the base of our triangle would be 12 centimeters. All right, so do you guys know why it's 12? All right. Since this is a radius of 6 and this is a radius of 6, we have to add it. So actually it would be a measure of diameter. And so from here, let's find the area of our triangle. So we have base times the height divided by 2. This is the formula that we will be using. And so 6 times 12, 72. 72 divided by 2 gives us 36. Square centimeters. And for our final area calculation, we have to subtract the area of triangle from the area of circle, and that would be 77 400 square centimeters. We don't have any specific instructions on how to round, so when you don't have these instructions, you would keep your numbers as they are. All right, let's scroll down. So this is going to be our first example, example number 2 right here. this shape seems very strange. You might say, Miss Hendricks, I don't know what this shape is. I don't know really what to do with this. So guys, look at this. It actually was a rectangular shape, and now the semicircle has been taken out of it. So our two shapes are a rectangle that's measured 6 centimeters right here by 4. Again, how do I know this? This is 2 centimeter radius. It's 2 centimeters radius. Give me the measure of diameter, which is 4. And this is really nice situation. We have a lot of comfort with rectangular, the area for rectangles. So 4 times 6 will give us 24 square centimeters. All right, so that was step number 1. And so for our step number 2, we have a semicircle. And yes, so now we have this measure right here. I'm going to just label it. So that's a radius of 2. When I work with semicircles, and when you work with semicircles, I would like for you to write down your formula for semicircle right away. You might say, well, there's not a formula for area of semicircle. Yes, there is not a formula. So you have to be extra cautious when you're working with semicircles, and don't forget to divide that area by 2. So I urge you to write down this the process right away so you don't forget to divide by 2. So from here I have pi times 2 squared divided by 2, which would be pi times 4 divided by 2, and that gives me 6 28/100. And so for my final step, my area would be 24, area of this rectangular shape, minus, so since the semicircle has been taken out, I am subtracting. So that's very important part of today's practice. You're subtracting this measure of the area of semicircle for the final answer of 17 72/100 square centimeters. All right. As you copy down the steps, take a moment to identify what is making perfect sense to you, what has been your struggle. If you're wondering where in the world the 4 comes from, again, a reminder is we are given the radius. So the 2 radii, or 2 measures of radius, will give you diameter, and diameter would be the measure of this side of a rectangular shape. All right, let's move on to shape number 3. In this shape, we have, I know the shading is not the best, but all of these little, seems like a bad printer, but this is your shaded area. So we had a rectangular shape, and then the triangular shape has been taken out of. Okay, so once again, we're working with rectangle and triangle, and take that step to separate your measurements. So for a rectangular shape, we have 6 by 10, base times height. Very nice mental math question. 6 times 10 will give us area of 60 square centimeters. For our triangle, everything is very nicely measured here, so there are no surprises. Our triangle has the height of 4, base of 5. So base times height divided by 2 is our area. A huge reminder, guys, do not forget to divide by 2. And so 4 times 5 is 20. Divide by 2 will give us area of 10 square centimeters. And our final area would be 60, large rectangle, minus 10, small triangle that's been taken out. That will give us 50 square centimeters as the area of the shape. And our last example, I'm going to scroll my note this way. Okay. So we are seeing a rectangular shape again. And I'm going to use different markers to show you. It used to be a rectangular shape, and then a rectangular shape was taken out of it from the side, from the edge. That's why my huge recommendation to you to break down your shape into simpler shapes as you're working. So 20 by 15 was the original shape. 20 by 15. So area would be base times height, 20 times 15. That will give us 300 square centimeters. 300 square centimeters. Then another rectangular shape was taken out of the original. And this is where the 10 by 10 comes from. So this is actually a square that was cut out of our rectangle. 10 times 10 is 100 square centimeters. And final step is a subtraction because the shape has been reduced. And that gives us the total of 200 square centimeters. As you go over these examples and use them for your practice, make a mental note what shapes you are feeling very comfortable with and which shapes you should be really cautious about. My other huge request for you, when you're working with circles or semicircles or any shape, make sure you're writing down your formula. With the semicircle, the formula is not on your star chart, on your formula chart. So please make sure that you are helping yourself and not forgetting to divide by 2 because it's drastically going to affect your answers.